Arifah Izzati binti Indra Shahrizad, and I will do an introduction part for forward and backward method. So, what is proof? In mathematics, a proof is a convincing argument expressed in the language of mathematics that a statement is true. A statement is a sentence that is either can be true or false. How about proving method? Proving method, it is a systematic way of demonstrating the truth of a mathematical statement or proposition. It involves constructing a logical argument supported by definition, theorem, axioms, and reasoning to show that the statement is valid in all cases. It ensures the argument is logical and free of ambiguity. It also demonstrates the statement is true for all possible cases. Lastly, it will help to verify that mathematical rules and relationships are valid. So, I will explain about forward method. When proving A implies to B, we will assume that A is true and use this information to reach the conclusion that B is true. When write the proof, we must use forward method. We will start from the assumption A to reach the conclusion B by going through several clear and logical arguments. The process involves deriving from the statement A, which you assume is true, some other statement is A1 that you know that is true as a result of A is being true. It should be emphasized that the statement derived from A and link up with the last statement obtained in the backward process.
Hi everyone, my name is Damia Maisara, and I'm going to explain to all of you the quick and easy way to understand the process of backward method. The backward method starts with a conclusion that we want to prove. And in other words, we assume that statement B and ask how or when can it be true. The backward method is used to help us reach the conclusion logically. There are three main steps that we need to use in the backward method. First, we begin to ask the key question: how or when can I conclude that B is true? Second, we give an abstract answer to this question based on the definitions or the known results. Third, we apply this abstract answer to the specific situation in the problem to obtain more concrete statement. After completing these three steps, we obtain a new statement called B1. If we can show the B1 is true, then the original conclusion B is also true. This backward reasoning is mainly used during the analysis of a proof, before writing the final proof. The rule of proof writing. This is what we're going to use when we answer questions. Analysis of proof is the thinking process before writing the proof. It applies the backward method by starting from the conclusion and identifying the condition needed for the conclusion to be true. And for the condensed proof is the final form of proof. It's written using the forward method by starting from the hypothesis and logically deriving to the conclusion.
For example 1, the question is, if m is an even integer and n is an odd integer, then m plus n is odd. We are going to do the analysis of proof. A, m is an even integer and n is an odd. This is the hypothesis. B, m plus n is odd. This is the conclusion. B1, m plus n equal to 2k plus 1 for some integer k. This is the definition of odd. A1, n equal to 2a and n equal to 2b plus 1 for some integer a and b. This is the hypothesis that is to be true. A2, m plus n equal to 2a plus in a bracket of 2b plus 1 equal to 2 in a bracket of a plus b plus 1. This is the substitution. And A3, 2 in a bracket of a plus b plus 1 equal to 2k plus 1, where k equal to a plus b. This is the simplification, so it is logically equivalent to B1. So, for the condensed proof, from hypothesis, m is an even integer and n is an odd, then m equal to 2a n equal to 2b plus 1 for some integer a and b. Since m plus n equal to 2a plus in a bracket of 2b plus 1 equal to 2 in a bracket of a plus b plus 1 equal to 2k plus 1 for some integer k equal to a plus b. Therefore, m plus n is odd.
So, we move on to example 2. The questions are, if q is an odd integer, then q squared plus 2 is an odd integer. Analysis of proof. A. Q is odd, which are hypothesis. B. Q squared plus 2 is odd, our conclusion. So, B1, q squared plus 2 equal to 2k plus 1 for some integer k to be shown from the derivation of odd integer. A1, q equal to 2t plus 1 for some integer t are the condition for q is odd. A2, q squared plus 2 equal to in the bracket of 2t plus 1 square plus 2 is a substitute of A1. And A2, q squared plus 2 equal to 4t squared plus 4t plus 1 plus 2 are simplification of A2. And then A4 is q squared plus 2 equal to 2k, where k equal to 2t squared plus 2t plus 1 are the simplification of A3. Which are the condensed proof for these questions are, given q is odd, so by definition q equal to 2t plus 1 for some integer t. To show q squared plus 2 is odd, therefore q squared plus 2 equal to in the bracket of 2t plus 1 square plus 2 equal to 2 in the bracket of 2t square plus 2t plus 1 plus 1. Hence, q square plus 2 equal to 2k plus 1 for some integer k where k is equal to 2t square plus 2t plus 1. The condensed proof for these questions are, given q is odd, so by definition q equal to 2t plus 1 for some integer t. To show q squared plus 2 is odd, therefore q squared plus 2 equal to in the bracket of 2t plus 1 square plus 2 equal to 2 in the bracket of 2t square plus 2t plus 1 plus 1. Hence, q square plus 2 equal to 2k plus 1 for some integer k where k is equal to 2t square plus 2t plus 1. The condensed proof for these questions are, given q is odd, so by definition.
For example 3, the question is, if m is an even integer and n is an odd integer, then 4 divides m squared plus n squared plus 3. First, we have to do the analysis of proof. So the first step is we have to write the A statement and B statement. A statement is hypothesis, which is m is an even integer and n is an odd integer. For statement B is the conclusion, which is 4 divides m squared plus n squared plus 3. First, we have to do the backward method, which is from B statement. So we have B1, m squared plus n squared plus 3 equal to 4k for some integer k. So this is the definition when the question say 4 divides m squared plus n squared plus 3. And then we proceed with the forward method. We start with A1, which is m equal to 2p and n equal to 2q plus 1 for some integers p and q. For m equal to 2p is the definition of even integer and n equal to 2q plus 1 is the definition of odd integer. Then we proceed with A2. We substitute the value m equals to 2p and n equals to 2q plus 1 into the expression. So we got 2p in the bracket 2p square plus bracket 2q plus 1 square plus 3. And then we expand the expression and we got 4p square plus 4q square plus 4q plus 4. Then A3, we factorize the expression in A2. So we got m squared plus n squared plus 3 equal to 4 in bracket p squared plus q squared plus q plus 1. Then for A4, m square plus n square plus 3 is equal to 4k for some integer k equals to p square plus q plus 1. So in this case, we have done the proving the A4 is logically equivalent to B1. For the condensed proof, given that m is an even integer and n is an odd integer, so we can assume that m equals to 2p and n equals to 2q plus 1 for some integers p and q. Then, we substitute m and n into the expression m square plus n square plus 3 and we'll get in bracket 2p square plus in bracket 2q plus 1 square plus 3 equals to 4p square plus 4q square plus 4q plus 4 equals to 4 in bracket p square plus q square plus q plus 1 equals to 4k, where k is equals to p square plus q square plus q plus 1 for some integer k. Thus, 4 is divides m square plus n square plus 3.
So, in conclusion, it is confirmed that forward-backward method provides an efficient way to generate a proof. Your goal is to lay out the proof and create logical paths from what you are given A to what you are attempting to prove B. Not to mention, this method is particularly useful for application involving probabilistic sequence such as speech recognition and time series. That's all from us.